There are several ways to troubleshoot a 550 catalytic bead system. You can test in the field, or you can swap components in the field and bring into house the parts to be tested under better conditions. An alternate instructional tool to this video is located in the 550 Operation Manual, Chapter 5, called Troubleshooting and Repair. There are three components in a 550 catalytic bead sensor and SafeCAL system that can be troubleshot: the SafeCAL and the transmitter and sensor. You can use any standard DVM capable of reading ohms, milliamps, and voltage. With the DVM on volts, place the probes on the plus and minus terminals of the transmitter. Although we spec out a 24 volt DC power supply, voltages from 20 to 28 volts DC are acceptable. To check the operating voltage of a sensor, probe the two outside pins, red and black, on the 4-pin sensor connector plugged into the transmitter. This reading should be between 5.6 and 6.4 volts, depending on the actual sensor elements installed on that sensor. For the next test, we would like to verify the performance of the sensor by applying gas and checking span. Place the meter on the milliamp scale and connect the black probe to pin 5 of the 5-pin transmitter header and the red probe to pin 4. If the sensor is mechanically okay and the transmitter is working, the meter should display a milliamp output between 1 and 7 milliamps, although we typically expect to see a value of 2 to 5 milliamps. Now you can snap on the sensor gas connector and supply a 50% LEL gas in air mixture to the sensor. A change in span from its zero reading, in this example 2.21 milliamps, to its span reading is called the delta change and should be approximately 3 to 3.5 milliamps on a new sensor to as little as 0.5 on an aged or poisoned sensor. In this example, our span is 3.8, giving a delta span of approximately 1.6 milliamps. This is a perfectly good working sensor transmitter assembly, indicating a sensor through about half its life. The next test is to prove we have a good working SafeCAL module. Plug in the SafeCAL and observe the display. It will display the software version for 18 seconds before going online. Since it is processor based, we must assume that if it is displaying legible words, it must be operating correctly. Now we need to know how to test the components as separate items. With the DVM on ohm scale, test an unpowered sensor, or actually the condition of the elements, by probing between the green and red wires of the sensor for the condition of the active bead, then the green to black wires for the condition of the reference bead. These values are typically between 8 to 12 ohms. To make the probe connections easier, a 4-pin mating header can be plugged into the sensor connector. The final check is between the green and the blue wires for the condition of the coating resistor potentiometer. This value needs to be between 154 and 190 ohms. More instruction on the coating resistor setting can be found in the instructional video 550-500 or in Chapter 5 of the Operation Manual. The next several tests will verify if a transmitter is functioning correctly. With the DVM on volts and the transmitter powered, probe the plus and minus power terminals to verify 24 volt DC is supplied. Next, connect the test probes to the two outside pins of the 4-pin sensor header on the transmitter. This will verify its capability to operate the sensor elements at a specific voltage dictated by the coating resistor. The voltage should be approximately 9 to 10 volts. Using a conductive tool such as a screwdriver or knife tip, short the two center pins on the 4-pin header. The voltage should drop to approximately 2 to 2.5 volts. We now have verified that the transmitter can vary the voltage from 2 to 9 volts depending on the specific coating resistor value of the sensor used. Hopefully by using the information given in this video, You can easily test components that you suspect to be bad by swapping them into a known working system. It will also give you a method to check if a sensor is functional or at the end of its life.